So in this video, we are going to discuss surface area to volume ratios and how cell size is related to that. We're going to use various objects like a marble, a golf ball, a tennis ball, a softball, and a basketball. Now these are all different size spheres, and they go from small to large. And this is going to represent what happens to objects as they get bigger in terms of their surface area to volume ratios. And so when we think about a cell, which is extremely small, why is it that way? You can see the pictures of those objects there. Now when we find the object's surface area to volume ratio, we need the radius for each object. Now radius is half of the diameter. So when we start with the marble, 0.75 centimeters, less than a centimeter, is the radius of the marble. We measured the golf ball at about 2.1 centimeters, tennis ball at 3.4 centimeters, the softball was at 4.5 centimeters, and the basketball was at 12 centimeters. And these are the radius of each object, half of the diameter. For this example, we're going to use the tennis ball, which is just in the middle of all 5 objects. The tennis ball had a radius of 3.4 centimeters. We look at a ball, all the way across would be the diameter. But that's not what we want. We want half of that. We want the radius. And so for whatever you get for the diameter, you just divide that by 2. The surface area of a sphere has its own formula. And the formula is 4 times pi times the radius squared. Anytime you see these numbers and symbols connected like that, that's always multiplication. So we have 4 times 3.14, which is the number we're going to use to represent pi. And in this case, for the tennis ball, it's 3.4 centimeters, so I included it there. Now, because of PEMDAS, you must do the exponent second. Remember, it's parentheses and exponents. And so when you take 3.4 and square it, you're going to get a new number, and that's going to be multiplied into the rest of the mix. And that number is going to be 11.56. Then you just multiply straight across to get 145.19 centimeters. That's the surface area. It should be centimeters squared. Now we're going to find the volume. The volume of a sphere is 4/3 times pi times r cubed. So we fill in some of our numbers here. 4/3 times 3.14, which is pi. But our radius is 3.4 cubed. So remember, we always have to do our exponents first before we do basic multiplication. So we have 4/3 times 3.14, which is pi. But then we have to find our cubed 3.4, which is 3.4 times 3.4 times 3.4, which gives us 39.3. Now, some people get confused by this 4/3 part. But really, all you have to do is multiply the numerator, 4, times 3.14 times 39.3, and divide all of that by 3. because really it's just basic math of fractions where you multiply the numerators and you multiply the denominators, and then you finally you divide the top by the bottom. So when we do that, we have 493.61 divided by 3, which equals 164.54 centimeters cubed. Now that we have both of these, we are trying to find the ratio of surface area to volume. Now, when you look at a cell, the surface area is the cell membrane. The volume is going to be the cytoplasm. And so nutrients and wastes have to be able to move through the cell membrane to get in and out, but the cytoplasm is where all the work gets done. So we want a really big surface area and a really little volume. So in our tennis ball example, we have 145.19. We're going to divide that by the volume, which is 164.54. And we come up with an answer of 0.88. And that is after we divided surface area by volume. Now, what does this mean? Well, it tells us something about the efficiency, but we got to compare it to other objects of different sizes. So when we compare that number, 0.88, to the other objects, we'll get a better understanding of the efficiency of that object if it were that size. And really what we're talking about is the efficiency of cells, how fast they get nutrients in and wastes out compared to what they're using on the inside. So the end idea is that the larger the ratio, then what we find is that the more efficient the cell can be. And when we talk about efficiency, the easier it is for the cell to get nutrients and get rid of wastes. And so the more efficient the cell is, then the easier it is for it to survive. Compare the tennis ball with the marble. What is that? And what is the basketball? And then you'll understand why a cell is small. I hope that helps. And as you are working through these problems, if you have any questions, make sure you ask them in class.